So, hello everybody, welcome to this webinar titled AI You Can Trust, Standards, Ethics and Innovation. This is John Soldatos from Net Company Intrasoft. This webinar initiated and hosted by the Talon project aims to shed light on approaches, but also standards for building trustworthy AI. This becomes increasingly complex as artificial intelligence becomes more sophisticated in terms of models, but in terms of the way this is blended within applications processes, also used for other things like infrastructure management. I have with me four excellent speakers: Professor Christos Emanuelidis from the University of Groningen, Lior Limonad from IBM Research, Sofia Karagiorgou from UBTech, and Professor Neta Polemi from Tastilio, with a lot of expertise from in the industrial aspects, but also in standardization and on the ethical aspects of trusted artificial intelligence. So I'm not going to say anything more about our speakers. I would like straight to give the floor first to Professor Emanuelidis. Christos, please feel free to take the time, introduce yourself and your speech. Thank you very much. And of course, we will have the opportunity to answer questions at the end of every presentation and at the end of the webinar. If you have questions in the chat, if you have questions that you want to write in the chat, feel free to do so, and we will convey this to the speaker. Christos, the floor is yours.
Thank you very much, John. Thanks for the invitation. Thanks for everyone present, and to my colleagues in this session. I'm already sharing. Can I just check whether what I'm sharing is?
It's okay, Christos. Please go on.
So we'll talk about trust in AI, and I would like to contrast that with trustworthiness. I'm Christos Emanuelidis, faculty member at the University of Groningen in the Netherlands. University of Groningen is actually the second oldest university in the Netherlands, with more than 400 years of operation. And it's a good environment to do multidisciplinary research on AI, as a university. It's not only a technical university, but hosts many disciplines, including social sciences. So what I would like to talk about today is, first of all, what's in there for me when we talk about AI and trust. So if you own a business, you are interested, of course, in the extent to which you can trust AI decision. If you are the recipient of services, customer support, and so on, you are interested in interfacing with such customers, and then interested in how, as a business, you respond to them. If you are managing operations, you are interested in improving the performance, for example. If you are an auditor or a regulator, you might be concerned with the AI outcomes being seen as being fair. Of course, if you are a technology provider, you might be interested in the robustness or the accuracy of your solutions. In any case, you are interested in whether you can trust AI. But one way of increasing trust in AI is using explainable artificial intelligence. But do you agree that this is of fundamental importance? I think it's probably a component of trust. But we used to say in the old times that you can trust, you can prove anything with statistics, and increasingly with the use of explainable AI, we have reaching a point when we can almost explain anything with AI. But whether that refers to trustworthiness of AI-enabled systems, that's a separate question, I would argue. And that leads us to seeking to explore more what is there in terms of trustworthiness. I'll just use a couple of quick examples from work unrelated to the project that I'm representing here today. So showing examples of using AI, for example, in design. I borrowed that from MIT Design Space. So you can do a lot more with AI rather than producing outcomes. So the kind of interaction that humans and AI have now is unparalleled. It's not the same as before. I think the best way to describe it would be that increasingly we are going to work with AI systems, I would say AI agents, by treating them as members of our teams. So you see another example here where you can try to do forecasting with a large language model, and the whole process is involves a lot of interaction with other team members. As you would do with your normal team members, you increasingly interact with AI team members. And in decision making, which is our concern in the Humane project, the human AI teaming is becoming very important. So it could be that the agency of decision making is still on humans. And in fact, it could be that some decisions are taken with no AI involvement at all. But we are used to perceive systems, AI systems, as decision aid and decision support. And that's another type of human AI teaming. But we increasingly have automation. And so we have AI systems making automated decisions, and in some cases, progressing with acting upon them. And then we can have this new emerging concept that we have a decision system that it's essentially the emergent outcome of human AI teaming. And that involves many iterations. It might be even not possible to separate the two when they reach an outcome. And that brings again the question of trustworthiness. So some work we currently do is about testing the trustworthiness of AI outcomes. You see here an example from multimodal data and trying to find benchmarks for testing that. But if we go back to standards, well, there are standards about trustworthiness, and they recognize as key concepts of trustworthiness those that you can see there. And that includes reliability, resilience, robustness, safety, transparency, usability, controllability, and so on. But basically, if you summarize that, trustworthiness of an AI-enabled system, well, is the system's ability to meet expectations in a way that can be verified, not just to be trusted, but verified. And that's different. So if we think about trustworthiness, we can talk about different layers of trust. So the cyber trust, the physical trust. So the cyber is more on the communication side and changing, in some cases, data while information is transmitted. The physical, so it's people working with physical machines or AI-enabled systems. And the social version of trust. Do we trust AI when we take action following recommendations by AI? And we recognize that there are risks related to that. So if we can borrow from NIST AI risk management framework, we can see all these characteristics of trustworthy AI systems. And then we can identify failure scenarios of AI-enabled systems causing harm to people, harm to organizations, harm to ecosystems. So this is a kind of a classification of AI risks, not fully consistent with AI Act, but very well worth paying attention to. But for automation of decision making, it's worth remembering how important is the controllability property of such systems. Can we have human oversight of an AI systems so that we can take action when action is needed? And then how about the transparency of decisions? So we have standards about the transparency of autonomous systems. And what does this mean for the human AI teaming in decision making? We can have decision making autonomy or we can have agency about it. But even when we have autonomy, it's important to recognize when the agency for the decision making should slide towards the human or back to autonomous systems and so on. So all this brings into play the importance of standards, and because the standards are the consolidated results of science, technology, and practice aimed at optimum outcomes and community benefits, it's actually quite important to follow them. And it's not a luxury to follow them. Because even if we are a small to medium enterprise, they can help us improve the quality of our services, drive growth, give us competitive edge and reputation, help us with new markets, enhance our credibility, help us comply with regulations or technical requirements, sharpen our business practices, and so on. And then, of course, there are standards from various organizations, and I'm not going to repeat that in detail here, but there are from international, European, or regional bodies, and so on. And depending on the domain we operate, actually, they can be domain specific ones, as you can see on the left side, on manufacturing operations or maintenance and so on. But in terms of AI standards, human factors, AI, automation, quality, and trust standards are very important. And I'll mention a couple of examples. So important questions there: who has the agency in decision making? And whether we can control the agency, because some decisions eventually will be automated. Whose fault is it when there are negative consequences of wrong decision making? And can we target at the same time our technical aims, our operational ones, and human factors? What's important to recognize is that when humans and AI work together, that expands the action affordances of each actor, whether it is a human or a non-human. We are able to do a lot more teaming with AI. And surprisingly not, AI is also able to benefit from human interaction, whether it is implicit from reinforcement or more explicit in terms of active learning and so on. Which brings us to the Humane project that actually employs a number of learning paradigms in that respect. So one of them is active learning, where the active learning mechanism steers the AI outcomes with interaction either from humans or with checking the machine learning process and directing it to reduce uncertainty or to optimize outcomes and so on. We use swarm learning to benefit from multiple agents working together, neurosymbolic learning to merge domain knowledge with data, and we use a lot of advanced AI and explainability and LLMs to have interpretable interactions with AI. And we demonstrate that in a number of use cases in manufacturing, in smart cities, in healthcare, finance, and energy. Just to give you a glimpse of the type of decisions we are dealing with dealing, for example, in smart energy with power grid management, in smart cities with management of citizens' requests and applications, in healthcare, management of healthcare services, for example, for diabetes patients and so on. So how best to take into account both the domain-specific requirements, the technical requirements, and standards and ethical needs? We employ evaluative and co-creative approaches, and we involve the stakeholders, initially the project partners, but aiming to expand beyond the consortium in a process that takes several steps. It's not a one-off. It's a process that we follow along the life cycle of the project. So we seed these workshops with our initial requirements, and we take into account state-of-the-art options and availability of technologies within the project, and gradually, step by step, we link those requirements to outcomes, and also we do a risk mapping process for each one of our cases, and we plan to do that at multiple iterations so that we test our solutions along the way to deliver on the social, operational, and technical dimensions. So just to give you an example of outcomes from such a workshop, we link decisions with objectives, data availability, options with AI, and then how that enables the different stakeholders to reach consensus on decision making, a term that we would call decision interoperability, so allowing them to share the same data or perspectives in reaching the decisions. So reaching to the conclusion of my presentation, just to say that AI itself introduces additional risks itself, and that's of course due to the complexity of the environment, the lack of transparency or explainability in some cases, the different levels of automation, impact of machine learning, hardware AI risks, and all those need to be looked upon from a life cycle perspective, from the design through the testing and validation, deployment, maintenance, but also decommissioning at the end, as we would do with physical systems, something not receiving sufficient attention. So examples of guidance on risk management from standards, I'm not going into great detail there, but these are very relevant for AI decision making. You can see the relevant standard there, and you can see an example of how we work with risks in the humane projects, or identification of failure scenarios, categorization of risk, attempt to assess the risk and prioritize the risk. Concluding, more standards that can be relevant by ISO, IEC, but also a lot about AI from IEEE, the P7000 family of standards, and the ongoing under development P339 family of standards. And talking about IEEE, quite some years ago that IEEE have put forward the ethically aligned design process, which could be relevant to many organizations. A few examples of what the Humane Project is about. I will leave those links. I guess this will be available after the webinar, but you can find more about the Humane Project. And to conclude, the impact of standards on AI uptake is down to an understanding of the value chain of the domain that we wish to apply AI to. And then within our organization, we need to identify relevant standards and their potential impact, link them with our value drivers, so operational, human factors, and so on, and measure the impact of standards, which is something we did also in a previous project, like in the STAR project, that you can see an example of that. And the message from that is that when you apply this perspective, you come to think of AI-enabled solutions conforming to standards and requirements as solution belonging to a design space of admissible solutions. You don't necessarily aim to optimize your solutions to multiple objectives at the same time, but because things change, environment, context, circumstances, you need to come up with a design space of such admissible, acceptable solutions and navigate your way through them. So that's the conclusion of my presentation, focusing even more on trustworthiness rather than on trust, because, well, think about it. How many of you have you, for example, trusted systems or maybe politicians that haven't been trustworthy? So trustworthiness is the real concept and the real value, and trust is of course important for the adoption. Thank you all very much.
Thank you very much, Christos, for the presentation and for keeping the time. so promptly and so consistently. I would like to ask if there are any questions to Professor Emanuelidis on this presentation. Feel free to raise your hand and then open your mic and ask the question. So from my side, I have two things that I would like to ask, which are related to a couple of your slides, right? The first question, and I'm gonna ask you both questions and then take your time to reply. So the first question relates to trustworthiness metrics. So trustworthiness is not about explainability, and transparency is one aspect, right? You have reliability and you have safety, and all these variate when you are in different environments, depending on how, what type of application you have, what type of environment you have, and what type of uncertainties. So I was wondering if in any of your approaches or in any of your standards, there is some way, some method, right, to quantify, to grade the trustworthiness, either to assign a score or to grade it as, high, medium, low. So this is question number one. Question number two, because you mentioned you use large language models, like maybe, I don't know, GPT or DeepSeek or Mistral, in these very complex systems, right? That, far exceed the realm of traditional deep neural networks. Is there a way to explain them and to understand how they think and how they take decisions?
I do
That's
seem
my
to have
second.
audio issues, John.
You heard my question or not? Yes. Did you hear my
Okay, my
question?
audio is back, I think. I
So
didn't
the
hear
first,
the last part. If you could just
no,
summarize
the
it.
last part is if we have a way to explain this very complex generative AI and large language models, right, with trillions of neurons, right? I guess the conventional way
Yeah,
to explain this do not work.
yeah, yeah. You're right. So explaining AI outcomes through the use of large language model, of course, is very helpful. But if we consider going into the internal workings of these models, okay, we may understand the principle of operation, how they're trained, how they produce their outcomes, but we don't really understand exactly how. That's far too complex. And sometimes we are content with the outcomes of human decision making. We have great decision makers, we have experts, we can trust them because they have provided in the past evidence that they are trustworthy, and they can provide arguments for that. But we don't know how their brain really works. So we don't know the internal workings. What we can observe, and it's the same in AI enabled systems, we can observe the outcomes. We can have hints about how they work, and we have to put all the pieces of the puzzle together. So it's not only a matter of explanation, it's not only a matter of trust, but we have to have verification means, documentation and reporting, so we have a trail of how the decisions are produced. That could include robustness testing, fact checking for the data. It might include detailed model cards for the type of data, training, and so on that the models undertake. So although it might come as a disappointment to respond to that there is no simple way of testing that, and that leads to trust, the more complex answer is that we need to put all the pieces of the puzzle together. What do these AI models or decision-making systems mean in terms of their trustworthiness, and put that into test with both less formal, explainable AI and formal ways, robustness testing, veracity testing, and so on.
Thank you, Christos. I don't see any other question. I hope I'm not missing thing. Maybe we have some more time for interactions in the end, all together with the other speakers. So I would like to thank you for this nice presentation. I hope we will be able to share it because there is also good reference material on the standards and the different aspects of trustworthiness. And I would like to move to a video presentation by IBM, Lior Limonad, and Lior is here also with Fabiana to answer any questions you might have. The presentation is about how can I explain artificial intelligence when I use it within an entire business process that that has much more complex context than just explaining a simple outcome of a state machine, like a simple classification or association. So, yes, bear with me as I share the presentation and feel free to write down your questions in the chat for Lior and Fabiana who are joining also us in us in this webinar.
Hi, and welcome to this online webinar. Today, I'll be presenting work carried out by IBM Research as part of the FAME project, funded by the European Union. My name is Lior Limonad, and I'm a senior researcher at the IBM Research Lab in Haifa, Israel. The work I'll present today was done in collaboration with my colleagues, Dr. Fabiana Fournier and Ina Skarbowski. Together, we've been exploring how recent advancements in AI can be applied across various aspects of business automation, and specifically how AI can be used to automatically generate explanations about business processes and how we might evaluate the quality of those explanations. We refer to this general approach as situation aware explainability, or SAX for short. As part of this effort, we have realized an open source library focused on developing core capabilities for causal process AI, a novel and foundational contribution to the field. Most organizations achieve their goals and deliver services through the execution of various business processes. A business process can be thought of as a sequence of tasks or activities that, when followed in a certain order, work toward an organizational objective, such as delivering a service or producing a product for customers. Recently, there's been growing interest in leveraging AI to automate parts of these processes, aiming to improve efficiency and speed. One area we are particularly focused on is process explainability. In other words, helping users understand why certain process outcomes occurred. Take, for example, a simple mortgage application process. At the end, the applicant either receives the loan or is rejected. If the application is rejected, the user may naturally want to understand why. It's important to emphasize that explanations, especially when generated automatically by analyzing relevant user data, can play a crucial role in building user trust in the service provider. That trust can in turn influence the user's intent to remain a loyal customer, in this case to the bank. So, the challenge is twofold. First, to automate the generation of process explanations. Second, to explore tools, ideally standardized ones, that can help us assess the quality of those explanations. Let's take a closer look at the concept of trust in AI. Torini et al. Identify four key aspects of AI trustworthiness, summarized as FEAS: fairness, explainability, auditability, and safety. Fairness refers to technologies that detect or prevent discrimination and bias across different demographic groups. Explainability focuses on providing stakeholders, including end users, with clear human centric interpretations of system outcomes. Auditability enables third parties or regulators to supervise, question, or monitor the AI system's operations, and safety ensures that the system functions as intended even when facing malicious or unpredictable behavior. In the context of AI powered business process management systems, explainability is seen as a fundamental capability, something that must be embedded in these systems by design. That's also why explainability is a central focus of our research. It's instrumental in fostering user trust, which in turn supports adoption and continued use of these systems. To make this possible, we need solutions that can automatically generate explanations that are not just accurate, but also understandable to both customers and the people managing the process. This becomes especially important when dealing with process outcomes, explaining, for instance, why a process ended the way it did, why a product was delivered at a certain time and quality, or why an unexpected result occurred. So, what is SACS? SACS is a framework that we developed to generate meaningful explanations about business process conditions. It leverages recent advances in AI to ensure that the explanations are not only sound, that is, technically accurate, but also interpretable and easy for users to understand. In addition to generating these explanations, SACS also includes an important component assessing how well users actually appreciate and understand the explanations produced. The overall approach is illustrated here. Our starting point is the process event log, a historical record of process executions within the organization. Each entry in the log typically includes a unique identifier for the process instance, for example, the ID of the service recipient, along with a sequence of activity names and their corresponding execution timestamps. Using the event log as an input, we apply a set of knowledge extractors that analyze the log and generate different perspectives or views of the process. These are processed by a set of computational services that produce three core views: the process view, which identifies recurring patterns in the sequencing of activities; the causal view, which uncovers how different activities depend on each other, essentially, which activities trigger others; and the XAI view, explainable AI, which provides insights into how various data attributes influence the outcome of process executions. These three views are then combined into an prompt for a large language model, LLM, along with the user's inquiry. The LLM uses this input to generate, synthesize an explanation that is tailored to the user's specific question. So once we have developed a mechanism that can automatically generate explanations, the next important question is, how good are these explanations from the user's perspective? In other words, how can we determine whether the explanation is clear, whether it is helpful, or even trustworthy in the eyes of the user? To address this, we developed a dedicated evaluation scale. Building on previous research and through careful validation process, we designed a scale that captures how users perceive process explanations. The scale combines two key dimensions: fidelity, the extent to which users believe the explanation is correct, and interpretability, how easily they understand it. It also accounts for moderating factors such as users' trust in the system and their curiosity or motivation to seek an answer to a specific question. We believe that over time, this kind of scale could evolve into a standardized way to assess the quality of AI generated explanations from the user's perspective. The next slide presents the list of 18 statements that make up the final version of our evaluation scale. Each statement is rated on a 1 to 7 scale, and together they are designed to uncover users' underlying perceptions related to fidelity and interpretability of the explanations. The scale also includes an additional set of 6 statements that measure users' perceptions of trust and curiosity. These are treated as covariates alongside the two main dimensions, fidelity and interpretability, to provide a more nuanced understanding of how users experience the explanations. As part of developing the scale, we conducted a user study to evaluate the quality of explanations generated by the LLM. The study involved 50 participants and covered three domains: pizza delivery, parking fines, and loan approval. The first two domains were based on synthetic data, while the loan approval use case used real publicly available data. We performed several manipulations of the knowledge input provided to the LLM, then asked participants to rate a series of explanations using the Likert scale. Our goal was to assess both fidelity and interpretability, while also considering the role of trust and curiosity as experienced by the users. Our results show that adding knowledge ingredients does, in fact, improve the perceived fidelity of the generated explanations. However, contrary to our initial hypothesis that these additions would enhance both fidelity and interpretability, this wasn't what we observed. As shown in the slide, adding knowledge ingredients improves perceived fidelity, but can actually come at the cost of perceived interpretability. In other words, while the explanations may seem more accurate, they may also become harder to understand. Moreover, this positive effect on fidelity is not guaranteed. It may disappear entirely when users have low trust in the LLM, and it tends to weaken when users have low curiosity about the question or outcome being explained. Still, our developed scale proved to be a valuable tool for assessing how much users appreciate and engage with explanations about different process outcomes. Once we had developed a scale to assess the quality of explanations generated by LLMs, we began exploring how the scale could be used beyond simply understanding user perceptions. Specifically, we looked into how the scale might also help in identifying which LLM models are more effectively at generating high quality explanations. In other words, the scale offers value not only in capturing what users think about the explanations they receive, but also in guiding model selection and refinement. With the rapid rise of available LLM models in the market, selecting the most suitable one for automating process explainability has become a real challenge. Different LLMs can produce significantly different explanations, even when given the exact same input. That makes it essential to embed a model in the system that keeps users both engaged and satisfied. To address this challenge, we launched another study, this time focused on evaluating how our scale could be used to quantify user perceptions and enable a meaningful comparison between different LLMs. The experiment centered on a tax refund process. We asked 128 participants to rate explanations for various tax refund decisions using our evaluating scale. In this case, our hypothesis was that perceived quality of explanations generated by different LLMs could be used to help rank and compare alternative models. Ultimately, guiding the selection of the most effective one. Behind the scenes, for the actual testing, we manipulated three versions of different inquiries about the tax refund process and used four different LLM models to generate the explanations. As before, for explanation generation, each LLM prompt consisted of description of three input views about the process with an instruction to generate an explanation for specific user's inquiry, such as why was I notified to correct my form and resubmit. We selected these LLMs to represent a diverse cross-section of the current LLM landscape in terms of scale, ranging from small 8 billion to large 70 billion parameters model, architecture, such as encoder decoder in FLAN versus decoder only in Llama, licensing, open source models like Granite and FLAN versus proprietary GPT-4o, and origin, community driven versus big tech labs. This selection enables meaningful comparisons that reflect the breadth of LLM design and deployment strategies. As shown in the chart, we calculated the average rating for the four different models across the two key dimensions, interpretability and fidelity. The visualization allows us to compare how each model performs on both aspects. Of course, different users may weigh the importance of interpretability and fidelity differently, but this kind of comparative analysis gives a clear, data driven way to guide the selection of the most suitable model for the task at hand. After developing the scale and conducting the user studies, we came to an important realization. Even when the goal is simply to choose between four LLM models for a specific domain, the process of running such evaluation is both time consuming and resource intensive. For most organizations, repeating this process regularly may not be practical. However, as we analyze the data collected from our studies, we noticed something interesting which I'll show you next. When we partition the participants' responses based on the four LLM models and the three inquiry scenarios, we noticed an interesting pattern. For both fidelity and interpretability, the distribution of user ratings began to take a shape resembling a Gaussian distribution. In simpler terms, for any given explanation generated by a specific LLM, user perceptions tend to converge around a certain average rating. This should, this should suggest that with enough data, it may be possible to train a predictive model that estimates the average user rating without needing to run a full-scale user study each time. We have begun exploring this possibility, but so far it seems that we'd need a dataset roughly 10 times larger to reach a meaningful level of prediction accuracy. To learn more about our work on SACS, you are welcome to explore our open source library called SACS for BPM. You can also check our related research papers where we dive into some of the theoretical foundations such as causal processes, how we develop the evaluation scale, and our parallel efforts to build a standard benchmark for assessing LLM's ability to reason about business processes. And of course, if you'd like to get in touch, feel free to reach out to us by email. This work was conducted as part of the FAME project, which focuses on developing a marketplace for exchangeable digital assets. These assets can include data and AI models, but in the context of our work, this could extend to include the use of our developed scale as a shared instrument, allowing users to contribute survey responses that could be exchanged or even traded among contributors. Over time, this could enable organizations not only to build their own knowledge base, but also use users' feedback to benefit from the collective insight from other organizations, helping them better understand how to craft effective explanations for their customers and how to automate the selection of suitable AI models for different use cases. We are also exploring a multi-agent adaptation of the framework where each agent specializes in a specific knowledge ingredient. In this setup, explanations would emerge from a collaborative conversation among these agents, each contributing their unique perspective. If you are interested in learning more about this work and future developments, stay tuned and follow the FAME EU project. Thank you for your attention, and I hope you enjoyed the webinar.
Thank you, Leor, for the presentation. Very interesting. And Fabiana, I was wondering if there are any questions to Leor and Fabiana on this presentation about SACs. Feel free to raise your hand and ask a question. From my side, I would like to ask the following questions. First of all, what is the role of open source here? You mentioned you provided your library as open source. Then when you compared the four models, this included, I guess, open source models and non-open source models. And despite the user perception about the quality of the explanation, isn't it better to rely on an open source model for the explanation, which is transparent, it is open to public scrutiny? So I would prefer, going with Mistral or DeepSeek because I can have the code and I can see how a certain parts works, whereas GPT-4 could be a nice people pleaser, in the way it explains things, right? But without any possibility to see so clearly the intrinsic processes. So one question is about open source. And my second question is which aspects of the SACS framework relate to standards or can be standardized? I don't know, maybe this could be built over a BPMN process, right? So to link it to existing standards. So two questions. First was about open source, especially in the LLMs, and how important is this for the quality and the credibility of the transparency? And the second question, what are the relevant standards here?
Okay, so like any politician, I'll start with the second question while I'll process a good answer for the first one. I think I have an answer for it. I'll say the following. I think that the standardization is a kind of instrumentation that eventually could promote usage. I think the problem, as was also asked in the chat, trustworthiness is key to with the exponent. I hope you can hear me. With the exponential rise of the amount of AI that is penetrating all different kind of technologies, we simply as users, we don't have time nor capacity to delve into the details of the inner working of each of these mechanisms. We need to have some means of standardizing to ensure that there is a sufficient level of quality accounted for in these mechanisms. So this is one kind of standardization, and the second is also presented in the talk, how we can actually assess the level, the quality of these mechanisms, not just objectively, but also from the point of view of the users. In our case, we developed a scale. These kind of scales will probably emerge in all over the place, and we need standardization to ensure that there is some kind of universal way to ensure the quality of these mechanisms, whether objectively or whether from the perspective of the user. Now, going back to the first question, I hope that was, sorry, I hope that was a good enough answer for the second question. For the first question, just
Yes,
need to
Leon,
keep,
go
I'll
on,
just
go
keep.
on.
So for the first question, sorry, I have an incoming call here and interfering. I need to.
The first question was about the importance and how do you factor the open source in the selection process, but also in general.
Yeah. So as for open sourcing, there is the one question I like asking everyone nowadays, and I will now adjust it to your question, which is my question, my classic question nowadays is, will you fly and you're sitting in an aircraft and it has just been announced by the pilot that the entire aircraft has been designed by an LLM, and will you still remain seated calmly before the aircraft takes off, or will you run out of the airplane? And now my question, adjusted to your question, is, will you care even if you know whether it was ChatGPT or whether it was one of the open source models when that announcement is made? Will you trust more an aircraft that was designed by an open source model, or will you rely more on one that was designed by some commercial company? To some extent, I think that standardization goes hand in hand when it's an open source model. For the closed one, usually, the commercial entity behind these models is the one that is typically considered held accountable for these methods. So in any case, we need someone we can blame if something goes wrong. When it is a commercial entity, we know who we can sue. When it is an open source model, we definitely need standardization. So this is my answer to your first question.
I would add that as part of IBM strategy, everything we develop goes to open source. So everything in Sachs library is open source. We encourage participants here and everywhere to try the services, to try the technology, so we can get feedback and improve it over time. And in the user studies, both of them, we used both open source and non-open source, just for a matter of comparison, as part of the study as well.
Thank you, Fabiana. So I think we will share the presentation, the video, if it's okay with you, and also the call for people to download and test the open source library. So yeah, you can also, like it was the case with Professor Emanuelidis, there are also some questions in the chat, but for the sake of being closer to the time, I will give now the floor to Dr. Karagiorgou. Please, Sophia, and then let's collect more questions. We have some buffer time to deal with this with all speakers on the chat. We have already something for Christos. Thank you, Leon and Fabiana. Sophia, please.
Thank you, John.
Good afternoon from my side too. Give me a moment. I hope you can all see my presentation in full mode at your side.
Yes.
Good afternoon. I'm glad being part of this very interesting conversation today, and I would like to provide my contribution on behalf of how Talon approaches similar challenges. Briefly, I will present you who we are and what we do and the challenges we are addressing the last 3 years, along with some breakthroughs that we have pursued during the project life cycle, and some ideas for novel and ethical things, keeping the same pace with AI advancements. And I will close my today's presentation with providing some ideas for future paths. So we are a quite large team from 6 countries, having academic partners, large technological companies, SMEs and research institutions, but at the end of the day, we have framed a unique end-to-end team. At a glance, Talon has introduced several prestigious and, let's say, ambitious concepts, introducing an AI orchestrator for automating the life cycle of the workloads on the pods, security constraints through the blockchain, and some security mechanism to safeguard how data is traveling in diverse infrastructures, and digital twins to put the human in the loop and boost AI explainability and trustworthiness. All these pillars have been coupled along with the objectives of the project and are materialized and grounded in different use cases and different pilots also, along with the respective key performance indicators for lowering the energy while training models, for getting the right decision while placing the models either at the edge or the cloud, for dimensioning the compute resources that are needed for both tasks, either for the inference or the training, and overall taking some smart decisions to orchestrate the edge to cloud continuum. Some challenges are faced towards standardization across the last years and are coupled with the Talon project relate to the dynamic and the continuously changing nature of AI and ethics. So as AI we all understand that is rapidly evolving, and it's not easy to define static ethical standards because
Sophia, sorry, accept a slight interruption. Are you switching the slides or it's a Teams problem?
Yes.
Because for some people it seems there is a delay, so they will come later. Maybe if you can reset
yes.
and then move to the slides where you have been, okay? Sorry for the interruption.
Thank you for letting me know. I wasn't aware that the slides were not changing at your end. Can you see now?
Yes, and you can try full screen mode.
Yes, maybe the problem was while changing now. Is it functioning?
My end, and I don't see the full screen.
Okay, let me try.
Now it changes, but I still don't see the full screen.
Let me try something else because I haven't multiple screens, so this should work. Now, can you see also the transition?
Yes, the transition and the full screen. Now it works. Thank you, Sophia.
Thank you.
And sorry for the interruption.
Thank you for the feedback because I wasn't aware, to be honest, and thank you. So again, recapping, the idea is somehow to ethical standards be adaptable and keep, let's say, similar pace with the new AI capabilities, also being agile to accommodate, let's say, new regulations, new principles, and new concepts. Also, overly prescriptive or premature standardization may stifle creativity and experimentation for research or academic institutions while developing, let's say, novel AI products. And maybe we need to consider how we could strike the right balance between innovation, regulation, and things that look restrictive, while at the same time we need the levels of dependence in order to come through with novel products and robust AI systems. In the front of defining and measuring novel and ethical concepts. Until now, there is some huge effort also in AGRA or DIRO and similar initiatives, but still some ethical principles remain abstract, including some concepts already presented by the previous presentations, such as fairness, transparency, accountability, and privacy, lacking clear and universally agreed definitions. So as a key takeaway, we need to start also having standards beyond let's say the streamlined and let's bulleted approach through some concrete and measurable directions that would facilitate further development, let's say, as key recommendations to be further pursued. Also, let's consider how we treat AI models, also including LLMs, that is also an emerging AI technology the last years. We treat them in most of the cases as a black box. In such cases, these models pose challenges for ensuring transparency and accountability, also bringing some key ethical aspects there. This was also shared in the previous presentations about the internals that we currently miss and the need to intensify the effort. Also, ethical considerations in AI may be context dependent. For instance, something that is not is appropriate for medical industry may be unsuitable for creative art industry. So even dealing with images, for instance, application still matters. Last, governance and enforcement. Now pushing forward regulations and principles. We have no currently a global consensus on AI ethics. So we have several and diverse regulatory approaches across jurisdictions, which introduced further complexities either for collaboration, either for development, but in a nutshell for adopting, let's say, a universal approach. Also, there is a need to establish some effective mechanisms for monitoring and enforcing AI ethical standards, particularly taking into account the advancement in AI, I mean the continuous advancements in AI, but also the opaque nature of AI development and deployment. Moving on, I would like to highlight, let's say, the three key areas where Talon has extended the state of the art, also bundled with some questions, research questions that have been answered in this project. So we are talking about AI, other training or inference, but in some cases we do not dimension the hardware that is needed, either for training tasks, either for serving purposes. So in this direction, Talon has introduced an AI theoretical model benchmarking over diverse data modalities and diverse data models, trying to solve a multi-objective problem, putting into, let's say, this multi-objective solution energy consumption while training, let's say, hungry models, compute resources, but also performance metrics such as accuracy, precision, etc. Also, a matter that concerns us was the coexistence of Talon in alignment with other, let's say, ethical and ethical principles and other regulations, such as the AI Act. As you understand now, heading towards the finalization, we haven't covered the full potential of the proposed regulations, but at least we have introduced a multimodal DataOps and MLOps pipeline, streamlining, let's say, the data curation, which contributes to the improvement of the data quality, the decrease of the data inconsistencies, the elimination of outliers, overall contributing to improving the quality and the veracity of data, up to providing explanations on the data and the models through, let's say, the features and, let's say, the core factors where the models have been have taken into account to derive their decisions. So in this direction, we have also introduced 4 different trust levels, reporting and scoring the quality of the data quality, the consistency about outliers, about missing values, the robustness, providing some, let's say, perturbations on the data, and also measuring their accuracy even in adversarial conditions. And last but not least, something already discussed and presented, the credibility and the fidelity of the model, performing various explanations based on the data modality. Also, another concern we had, it's what are the options we have for AI model serving either at the edge or cloud, taking into account that we have energy-constrained devices such as UAVs, hypothetically without having, let's say, permanent power supply. So the positioning of the Talon, it's a zero-touch smart orchestrator, taking some smart decision, having already dimensioned the pods and the workloads, where the decisions contribute to having smart placement of specific workloads, either at the edge or the cloud. On the front of standards, ethics, and innovation, here I would like to, let's say, draw some key takeaways on some novel aspects that we have considered in Talon. So revisiting the challenges of AI and ethics in Talon, building these streamlined data ops and MLOps pipeline enables to detect, report, and promptly correct data and models issues. So having, let's say, a clear pipeline, promptly reporting issues upon their arrival, upon their detection, it led us to spot the issue and take corrective measures. Also, revisiting the challenge of black box, that in most of the cases we don't know the internals and how the model has derived its decision. I would say that the combination of the trust levels, the scores, the fidelity scores, and some blockchain mechanisms that help us to trace how models evolve across multiple trainings, to also trace if something has changed to the weights of the models, is an answer of how we try to even tackle decisions derived from black box models. Last, revisiting the challenge of what is novel versus ethical, I would say we have adopted a fit-for-purpose approach where it seems it's beyond data nature. So we have coupled per pilot the specificities, taking into account diverse requirements and also aspects about innovation and how an AI model deployment is ethical or not. I will not. I don't want to get into much details here, but I would like simply to to draw your attention that across the 4 pilots of Talon, ranging from UATV's coordination to human-robot collaboration, and also applications in the industry domain, even similar models had to be fine-tuned properly in order to fit for the application case and data origin. As closing remarks, the discussions on standards, ethics, and innovation as we have today are not independent threads, but rather pillars supporting a future where AI empowers humanity responsibly and equally. So establishing trust in AI should be considered as a continuous journey and not a destination. And ethical considerations somehow should act as a compass that help us somehow guide the AI trajectory or even fine-tune or correct it accordingly based on the application and based on the needs. As an outlook, it seems both from the diversity of the disciplines in Talon, but also from the diversity of the problems and the challenges, that again here we need to approach it, let's say, in a disciplinary way to boost the collaboration, operationalize ethics, which means deriving practical guidelines and not, let's say, abstract rules, and also accommodate this into adaptive and agile standards that can keep the pace with the advancements along the AI, somehow acting as living documents. And this is the end of my presentation. I would be happy to answer any questions you may have.
Thank you very much, Sophia. So now it's time for the questions. Feel free. I see people write on the chat, right? But they are shy, to raise their hand and ask. So we have different questions in the chat. Let's brief them later. Sophia, I would like to ask you something about the zero touch orchestrator. Is this adapting according to is it adaptable when it manages, different AI workloads in the edge or the cloud? And what specific metrics are you using to evaluate the performance of this orchestrator? It was your point 3.
I would say multiple metrics. Starting, I tried also to stress out this in the presentation. These are working in a sibling manner with the AI theoretical framework. So in parallel, we try to both dimension the hardware per se, which means computing resources, time, RAM, CPU, because every pod at the end of the day lies within, let's say, some cloud or edge resources. And at the same time, we also record energy consumption along with the performance metrics of the different models. So this, at the end of the day, logging, let's say, this behavior and this information, we derive patterns. And after performing a kind of multi-objective problem solving, this let us, so the golden mean is at the same. So if I want, let's say, the best model scoring 100% of accuracy, I need to sacrifice energy or even I need to sacrifice time or cloud computing waste. So through this example, I would like somehow to draw that the golden mean is, let's say, in the middle. So that's why this multi-objective tries to propose solutions for the orchestrator in order to not sacrifice accuracy at the same time while sacrificing energy or compute resources. And at the same time, taking it specifically for the edge deployments, taking into account that most of these devices are energy constrained. So we have drones that are occupied with batteries, and the battery has a very specific lifetime. So in these deployments, we also consider the energy consumption in order, not to, let's say, result into starvation.
Hey, thank you, Sophia. That's clear enough. So I invite people, to ask the questions to the speakers, not just on the chat, but we welcome also questions in the chat. And with this, I would like to thank you, Sophia, and then move to our last speaker for today, Professor Polemi, company Trastillo. But not only this, probably Professor Polemi has a lot of experience working with standards development organization. So the floor is yours. Feel free to introduce yourself and your presentation.
Thank you very much, Ioannis, and thank you for inviting me. And my presentation, I am professor at University of Piraeus, Department of Informatics, also CTO in a Dutch startup. It's called Trastillo. And let me try to share here because this is always an issue here. Okay, can you see my slide?
Yes, we
Okay,
can
so
see
nice. Okay,
full
thank you
screen
very
mode.
much.
Excellent.
Okay. So my presentation today will just provide some challenges and some efforts that we see in the area of trustworthiness of AI. And as the previous speakers and their interesting presentations, of course, they mention about trustworthiness many times. And we see that in AI Act, which is the piece of legislation that actually we really study very in detail and try to find standards, find ways, methodologies to implement what is written in this AI Act. We see that Articles 10 to 15 actually, if you like, they kind of define the concepts of trustworthiness, which include accuracy, robustness, cybersecurity, transparency, data governance, technical documentation needed, and so on. Also, very important article is 9 that talks about risk management. And here is an issue of what we mean by risk management in the sense of AI Act. Do we mean cybersecurity risk management, something that we are, this is something common for any ICT system? The answer is no. Actually, AI Act talks about trustworthiness risk management, and this is something I would like to further analyze here. And another, in Article 43, that we see conformity assessment. And what does that mean? That we need conformity assessment because finally, after all, at the end of the day, we need certified AI systems. So conformity assessment is required. The Commission is working a lot in implementing and trying to implement and adopt the AI Act, and I would like to probably you have seen that document. This is the first framework that ENISA published on how to deal with AI systems. And the idea in this framework was that, in order to have the cybersecurity aspects of an AI system, in order to be secure, we need to follow good cybersecurity practice as usual. So we need to have the cybersecurity foundations in place. Then consider in which environment this AI system operates. So there you can add additional threats and specificities and vulnerabilities that this AI system brings into the picture because of the environment that operates, and also at the phase of the life cycle the system is in. And finally, in the third layer, then you need to consider the sector, the specific sector that you deal with. Are you in the health sector? Are you in any other critical sector? Because we may have sectoral threats that that the AI system inherits and we need to deal with. So in this framework, we see the approach is the scalable approach from foundations to final sector-specific threats that we need to consider. Of course, there are standards, and there are standards. The colleagues before had a very nice presentation, Professor Manolidis, about the standards. And of course, we have standards for quality management, something that AI Act requires for the AI systems, quality for cybersecurity management, for the robustness, and specific AI standards for the AI life cycles, for evaluating threats of AI. We have privacy standards. So ETSI also has published some two standards for the telecom AI system, the 001 and 2, and also have this report from ETSI. So we do have standards. The question here is, how can we use these standards, and do we have methodologies that really implement these standards? A big challenge is that standards are not harmonized, and one of the requirements of the AI Act was to harmonize the standards. So the Commission actually made a request to the two European standardization bodies, namely ETSI and CEN-CENELEC. CEN and CENELEC are two, but they operate as one, and their standards. So the Commission has provided the request, and in order to really harmonize the standards, and we are in the process. Actually, CEN-CENELEC with the Commission work together in order to implement this standardization request. And the steps to follow that will be followed and are being followed is that CEN-CENELEC actually has formulated joint technical committees, like number 21 and number 5. And these working groups actually, they are working with other stakeholders, with the Commission, with industrial associations and so on, to draft and actually harmonize the standards that are already in place, harmonize in a way that they can be useful. And then, of course, at the end, the national standardization bodies will vote on the proposals that the CEN-CENELEC will make with the Commission in order to publish them in the official journal of the European Union. So we are in this process, and in the year to come, I think we will have big progress on harmonizing standards. And actually, what we really need is that a person, an entity that works in, depending of the sector that works in, depending of the specific AI system that operates, depending of his professional role, he needs to find a specific standard and methodological standard as well to implement the standard. So actually, we do need such taxonomies in order to deal with this plethora, chaotic sometimes, overlapping time standards. And the second challenge now, besides harmonization of standards that we see there is a big progress on that, the second challenge is risk management. Article 9, as I said before, requires risk management of the AI systems. And here they consider this, of course, as a continuous process throughout the AI life cycle. So it's not like the static ICT systems that we do it once, frequently, but once as it's a static system. But it need continuous during the phases of the AI life cycle. And of course, AI Act refers also to NIS2, the GDPR, the CRA, and as we all know, all these legislation instruments talk about risk management. We all need to do to assess our system against against threats that actually have impact to our operation, to our system, to our company, to the society. And but here the difference is that up to now we had to assess all the threats regarding to security and cybersecurity risk management, up to now threats against the dimensions of security, confidentiality, integrity, authenticity, availability, non-repudiation. These were the dimensions of security. So we had to assess threats, we had to assess our ICT system against threats that impact the dimensions of cybersecurity, and we needed to evaluate the vulnerabilities, the impacts, and finally to estimate the cybersecurity risks. Now, with the AI Act, we are asking to conduct again risk management, but for trustworthiness risk. And here is an issue because the dimensions of trustworthiness, if we agree that these are the ones that are mentioned in the AI Act, so security, accuracy, robustness, transparency, and fairness. So the key is the threats. Unfortunately, not only technical threats, but they are also social threats. And not only social threats, but also psychological and social and ethical threats that we need to consider. So you don't when you were doing cybersecurity risk management, cybersecurity experts were enough to be involved. But here, for the trustworthiness risk management, we need more. We need to collaborate with social scientists and psychologists if we want to really complete and trustworthy risk management. We also needed we need also some practical efforts in order to conduct, for example, AI vulnerability assessment. We need the repositories of threats, repositories of AI vulnerabilities, and of course the NVD, the NIST, the National Vulnerability Database, can be used because they keep up enhancing NVD with AI vulnerabilities. Also, ASPA has been very active, that has conducted this very nice portal that we can find controls, threats of AI threats and suggest controls. Also, we need some incident databases. What is an incident? What is an AI incident? So, as a cybersecurity incident is any event that actually can impact in a negative way your system. The same thing here, an AI incident may be an event that impacts, has negative consequences, let's say, to your AI system. But the question is, do we have any database we can work on? Well, there are some starting, let's say, efforts, starting with this AIED, a Californian-based entity that has developed this. Also have this MIT AI risk repository that actually is using the previous one in order to classify AI incidents and provide some controls. UK AI Instant Response, it's only a website that people can actually use and upload incidents. And we see the latest announcement from ENISA that actually they have a tender actually out that they will develop an EC, a European National Vulnerability Database, that hopefully, of course, we will have AI vulnerabilities posted there and will allow the Europeans to upload AI instance as well in this new development of ENISA. Now, there are various projects actually that are dealing with the implementation of AI Act, and here is one, FAITH. I participate in that, and in this project, we are developing a trustworthiness risk management framework and a tool eventually that actually is based on ISO 27005, because after all, the phases of any risk management are the same. You identify threats, you evaluate, you identify vulnerabilities, you identify your implemented controls, you estimate your risks, you undertake controls, and you treat. The difference, the enhancement here is we use this flow of ISO 27005, but we have this faith repository. Of course, we use the AI OASP repository, but a more enhanced repository that has all AI threads and controls suggested. Also, we took into account the human factors and use this tool, it's called TrustSense, that actually evaluates also the maturity level of the teams that deal with and they are involved in the AI life cycle, because as AI access that imposes the AI, the human oversight. But in order to have a human oversight and also have humans involved and to understand the decision, to undertake controls, you need to have mature AI teams that are capable of doing so. So we have collaborated with social scientists and psychologists here to have this tool in order to put this into the picture as well and increase or decrease the risk levels according also to the maturity of the team's trustworthiness level and maturity level. Also, this faith framework, actually this trustworthiness risk management will also be an iterative process that can be applied in every stage of the AI life cycle. Next challenge, Article 43, as I said in the beginning, is the conformity assessment. And the question is, we need AI systems that are certified, and what that means, we need actually to assess the AI trustworthiness requirements that have been actually mentioned in a protection profile. I remind you that we have trustworthiness risk management in order to also to develop a protection profile of an AI system, in which in the protection profile we have the requirements of the trustworthiness requirements of this AI product. And then when you go to the auditor, what does the auditor does? He conducts a conformity assessment in order to assess whether the claims in the protection profile are valid. So these are the processes from the manufacturer side to conduct trustworthiness risk management, and from the auditor side to conduct a conformity assessment in order to assess the claims in the protection profile. And here is another challenge, and the big challenge here is that they are not standardized trustworthiness schemes that auditors can use. We do have, however, the ENISA European cybersecurity scheme that actually provides all these components that the scheme may need to have. And actually, we also have standards like the 17065, 15408 common criteria, which is the 15408, 18045, a methodology that actually implements the common criteria. We do have the tools actually to use and also conduct to create protection profiles for AI systems. But of course, this process needs consensus with vendors. And so let us see this for the future. EUCC is there to use. Projects actually try, like Custodes, is trying to automate the conformity assessment process, to automate the protection profile generation. And this is, we see a lot of research efforts there. A big problem, of course, again, is a challenge that we don't have certification authorities for AI systems and products. So this is let's see if the CABs that we already have established in Europe at least, probably they will undertake the role of being AI CABs as well. Last challenge is the training on AI trustworthiness. And here we see that Sensenelec actually used the ECF. ECF, I remind you, is the European standard that the Department of Informatics, let's say, we use to create and develop our syllabus in our cybersecurity and all IT courses. So ECF is being used here by Sensenelec, and actually the they mention here, using the scheme of this ECF, of what type of knowledge and how type of skills are needed for AI. Europe, though, and ESAC has, in 2023, has established this European cybersecurity skills framework that actually, at least for AI cybersecurity professional roles, we can find a lot of information to see what skills and capabilities are needed for the AI cybersecurity professionals. And however, we still we see the TEB program that has funded a lot of projects for training. And actually, the encouragement here is like those three projects for training, that we use ECSF in order to provide the capabilities and skills needed for the cybersecurity professional roles. And that will be a nice start to consider this standard, the ECSF, for the AI cybersecurity roles. So the way forward is to finalize the harmonization of standards, to consider the trustworthiness risks, which are so dynamic, and we need standard measurements for trustworthiness risk management. And because the static measurements that we already have for cybersecurity are not realistic, so we need more dynamic for all stages of AI life cycle. We need to harmonize the standards. We need a global framework of trustworthy AI. We need to work on with social scientists and psychologists in order to agree on some thresholds. What is the trustworthiness risk appetite we will adopt globally eventually? This is an issue. Of course, human in the loop and human oversight, but not only human oversight, but the whole, in the entire loop of trustworthiness risk management, we need to have humans in this loop. And as I said, to advance conformity assessment, because at this point, the even common criteria, the standards we have, they need some twist in order to apply them for the conformity assessment of ICT system. We need to get together and agree, reach consensus with vendors that actually manufacturers of AI system in order to create protection profiles of the system and finally be able to certify and assess the claims in these protection profiles. And finally, of course, we need trainings. And at this point, let me advertise the cybersecurity summer school that we are organizing in Cognac, Crete this end of May, and you're all welcome. AI, actually, for cybersecurity in this dimension, there will be some trainings there, and you're all most welcome. And that will conclude my presentation, and thank you very much for your attendance.
Thank you very much for the presentation, Professor Polemi. There is a question from Giacomo. So Giacomo, please feel free to ask your question, but also just to prepare, there was I think the last this presentation links very well to one of the questions in the chat, which is what is the link and the relationship between AI trustworthiness assessment and standard risk management framework for security, for cyber security, and so on. This was, by the way, a question in the chat a little bit earlier. It is answered in the presentation, but maybe you can do a synthesis and give a best answer to this, and then take Giacomo's question.
Yeah, I saw that in the chat, and I just was hoping that this presentation will respond. And so when you do cybersecurity risk assessment, as I said, you try to analyze all risk of all threats that actually impact the dimensions of cybersecurity, integrity, confidentiality, authenticity, and so on. And here for trustworthiness is something much bigger, because here you go on all the threats that impact all the dimensions of trustworthiness. Cybersecurity is only one. We also have privacy. We have accuracy, transparency, explainability, fairness, and so on. So what are the threats? And how do you estimate the threat levels of these threats to your system? How do you estimate the vulnerability levels, the impact levels, and finally, how do you estimate the trustworthiness risks of all these threats to all the assets in your ICT systems? So the question is the same, but in a broader context.
Okay. We just made the complex more difficult. Giacomo,
Exactly.
please.
Makes life more interesting like this.
Okay. Giacomo?
Hello. Hi. My question, thank you for the presentation. My question is related to your point throughout the presentation about having teams with a multidisciplinary background, dialogue across disciplines. And how do you connect, because each discipline has also developed its own vocabulary, definitions, different understanding of threats, different understanding of risk. And then there is a policy objective of harmonizing standards, right, to unify this approach. Do you think that in order to achieve this harmonized approach, each discipline needs to give up or to find a common ground in a certain form? Or is there a certain kind of approach that should prevail, like, I don't know, technical standards should be the starting point, and then social science should just enrich them? How do you see this?
Well, I just hope and I feel, this is the first step that needs to take place. Thank you, Giacomo, for this question. The first thing that I hope Sensenelec will come up with is with a vocabulary that we can all communicate with. Of course, there are many attempts. OECD, ENISA, we have NIST, we already have some vocabulary, but we need a standardized vocabulary. For example, cybersecurity terms, we have the ISO 27000. This is a vocabulary we use, all terms of cybersecurity. Also, JRC has, we developed there in the commission a vocabulary for cybersecurity terms. Hopefully that also ETSI has a vocabulary. So I hope the commission will adopt one vocabulary of terms and that we can all use the same terms when we talk. Because a very big problem, especially with legislators, with social scientists, because they use the terms differently. So we really need some standardized vocabularies to communicate across all disciplines, because all disciplines are needed. For example, ethical threats need, for example, legal experts to help us out to see what is ethical in the terms of not only technical, in terms of law or privacy. For example, the stakeholders from the legal perspective need to help us. Or bias, what is bias and what explainability? Explainability for whom? Which audience? At which maturity level should this audience be in order to understand the explanations you provide? So all these are concepts that do need multidisciplinary explanations, and in order to communicate, we really need a standardized vocabulary of terms. So you can all use the same. At this point, if this does not happen, my proposal is for cybersecurity terms to use the ISO 27000 and for AI terms to use ETSI. Unless something else, or we see something else from the Commission that will adopt. There is a big problem with the legal instruments as well, because even in the legal instruments, these NIS2, CRA, they use, even the legislation, different ways of terms. I mean, what vulnerabilities it was in NIS, they use it differently in NIS2. So I don't know if I hope I answer your question, Giacomo.
Thank you. Christo, Professor Emanuelidis, you wanted to reflect on something on the previous maybe issue topic, which was addressed to you or another?
I think in this question about trustworthiness in general, in broad terms, trustworthiness is the ability to meet stakeholders' expectations in a way that can be verified. And in that sense, trustworthiness is an attribute that can be applied to services, to products, to systems, to technology, to data. It may even apply in the context of governance. So we can discuss about trustworthiness of a specific AI-based service, product, system, and so on. Now, when we are thinking about the trustworthiness of an AI-enabled system, it's important not to forget the context of the domain. Not only consider trustworthiness in AI terms, but in terms of trustworthiness on the domain of specific system. So, for example, we employ AI to manage our power grids or something else. How does AI help us to enhance the operational availability of that system or a service related to that? How does it help to improve the efficiency of operations in this domain? So the point is that when it comes to discussing AI trustworthiness, we need to discuss both in terms of AI itself, but especially also to have a domain relevant understanding of what trustworthiness means. That was the point I wanted to add.
Okay. And as we move close to the end, thank you, Christos. Let me rephrase in simple terms another question from my colleague Yannis Chrysakis on the chat. If LLM is a black box, then does this mean that in highly regulated areas and domains in the EU, like for example healthcare and so on, we can't use for example GPT-03 for a medical diagnosis, which is a high risk application, since there is not adequate transparency, right, on how GPT-03 works, for example, or in very simple terms, is it illegal to use LLMs in black box LLMs in applications in Europe? I don't know who wants to take this question, and if Yanis wants to add something, but this is the way I perceive the question. Yes, please.
Well,
Ineta, you want to ask? Yes.
I think that this would depend on the trustworthiness policy of the organization that hosts the system. So the one that you just mentioned here is a mitigation action of a risk against the dimension of transparency. So yes, in a hospital they may have this mitigation in order to prevent any risk that impacts the transparency of the system. That they may have the mitigation action not to use ChatGPT. It is a mitigation action. I think we will see that depending of the how critical the environment or the sector or the system is, then we will see that the organizations, the entities, they will develop trustworthiness policies that will vary according to their needs. So, yeah, in my view, this could be a mitigation action and would be acceptable.
Thank you. Adrian, is this on this, or Christos, is this on this? And then we can have Adrian's question.
On this one.
Yes, please. Christos?
So the question by Ioannis Chrysakis is a very good one, and I try to briefly respond to that in the chat, really. The ambition to have a full transparency of LLM models is understandable, but is it pragmatic? they tend to have this, I don't know, billions of parameters and so on. What does it mean to have transparency? We use LLMs to have contextual explanations of what other AI models do, or maybe some summarization of what themselves are doing. But do we really expect full transparency from LLM models? I think testing and verification of LLM model outcomes is even more important than expecting explainability and transparency of LLM models. And the crude example that I try to use is that, well, sometimes we take at face value where human actors tell us because we trust them, but still we probably scrutinize what they're saying. Is it, how about the veracity? I mean, is it, if we put that into test, does it stand? And we should be doing the same for LLM outcomes. We should be putting their outputs to test and verification and scrutiny. That we can do, but the full transparency of LLM outcomes or the way that they are produced, it could be a mirage.
Thank you, Christos. Adrian, you have another question. Please feel free to.
I do, Johannes, but I see Johannes has his hand up. Maybe I'll let him speak first if he wants to respond to the answers he's just received to his question.
Okay,
No, I
Yannis,
would like to. Yes, thank you. I would like to thank everyone for answering my question. So, do you think that this full transparency of LLMs is the next big challenge of building the next trustworthy AI systems? Is my question for the future. So, what do you see? What do you see that it will be the next big challenge for building a trustworthy AI system for the next, let's say, 10 years? What do you think?
Well, I think, Yanis, I think the part of the answer was that you should not, you cannot explain a big brain, a big artificial brain of 1 trillion neurons, right? But you could possibly explain a specific outcome, right? So why for this specific patient in this context and with these examinations, you got this diagnosis, for example. Okay, so basically, I think that part of the answer was that the problem, you simplify the problem to explaining an outcome than trying to explain how the entire brain works. But I don't know if there are more reflections, but just bear in mind that we need to give Adrian some time because in 5 minutes the webinar is closing, so we need to give Adrian a chance to answer his question.
Thanks, Johannes. Thanks to the panel for the presentation today. I have 2 questions, 2 quick ones for all the panelists and everybody else here, really. So I want to know what the panel think of sandboxing, because I didn't hear a lot about it today. But like in terms of trustworthiness, what do they think the value of sandboxing is going forward? And the other one is to take Johannes's question and turn it another way. It's that what about Europe building its own large language model or general purpose AI system? What do the panel think about that in terms of our ability to, as Europeans? I should say I'm CEDAR UCD. I'm in Ireland right now, so a proud European. And I'd like to know what the panel think about building our own large language model or general purpose AI system. What do they think are the challenges and opportunities in that regard? Thank you very much.
Okay, so somebody from the panel wanting to respond to these 2 questions?
Thank you. If I may relate to
Theodore,
sandboxing,
let's go.
not sure I have. I need to
Sandboxing
think.
was the first question. Yes.
Yeah, as before, I need to think of the second question a little bit more. But for the first one, sandboxing, I think this is like a test drive. I think it helps building initial trust in the system. I think anyone doing that knows that it doesn't give the entire breadth of context was mentioned, the entire breadth of actual context in which the system will eventually need to function. So I think it gives a good start, but I think that in the longer term we need there has to be building trust is also about the reputation of the entity that stands on behalf of whatever AI mechanism is being generated. We don't have, as I mentioned before, we are using many complicated systems. I don't know. No one knows the inner working of their operating system that they are using now on their own laptop. So this is exactly as the complexity of an LLM model. It's not about understanding the inner working. It's about our ability to actually trust the entity that provides that, and also in time build and eventually develop the trust in using that system. So I don't think it's on the technical matter of understanding how the LLM works. I think we are losing a grip on that actually.
Okay, makes sense. Any other reflections on the subject? We have 2 minutes left. If anyone wants to speak, I think sandboxing could be a nice mechanism for testing things, right? So that you actually become trustworthy, right? Because to offer a trustworthy product in the market, right, and high quality product, you need to test it, right? To test it thoroughly. And sandboxing is a way to go on testing on real conditions. I can also reflect on what Professor Polemi said, that with this trustworthiness and AI challenge, we can be building on top of existing standards, risk assessment frameworks, mitigation mechanisms, and so on. So we have to deal with a larger scale problem, a more interesting problem, but the main underpinnings of trust and security and cybersecurity still remained valid as such. I would like to thank everybody for participating in the webinar, and a special thanks to speakers for their active participations in giving answers, the excellent presentations. We will be sharing the recording, we will be sharing the presentations, and we will be certainly keeping in touch with all of you for developing further activities and further synergies. Thank you very much, and enjoy your rest of the afternoon or the evening.
Thank you, everyone.
Thank you,
all.
everyone. Bye.
Thank you very much.
Thank you, everyone. Bye-bye.
Thanks a lot. Bye-bye.
Thank you. Bye, everyone.
Bye-bye.